All right, we are moving on to lesson 5 today. Because there's no new lesson notes, I'm going to just get right into the examples. The center of a Ferris wheel is 40 feet off of the ground, and the radius of the Ferris wheel is 30 feet. How high off the ground is each of these positions as the Ferris wheel moves counterclockwise from zero? So, a couple things we need to consider here. We are first looking for how high off the ground we are at each position. So if we're looking for height above the ground, are we going to look for X value? Or are we going to look for Y value? Okay. Height off the ground is vertical height. So which one is vertical? X or Y? In this case, it's Y. X, remember, is horizontal. Y, remember, is vertical. So how high off the ground means we're going to look for just the Y values at each of these angles here. Another thing to consider, let me zoom in here on the picture of the Ferris wheel. For one, this is not a unit circle. The radius is not 1, the radius is 30 feet. So that's one thing to consider. The other thing to consider is that the center is 40 feet off the ground. So when I plug into this formula right here, since I know I want to find the Y value, when I plug into that formula there, and I get an answer, the answer that the calculator gives me is not going to be the actual height. Okay, that's going to be that answer is going to be the height in relation to the circle. So in order to find the actual height, I have to plug into the formula that I circled in green, and then I have to add 40 to it since the center is 40 feet above ground. Okay, if the bottom of the circle was at ground level, that would be a different story. But because the circle is because the center is 40 feet above ground, I have to add 40 to whatever answer I get to the Y value. So looking at part A, okay, A is 20 degrees. So on the circle, that's going to be about right here. So 20 degrees will be approximately right here. And again, I know that the radius is 30 feet. So to find the actual height, I need to plug into that formula and then add 40 to it since it's 40 feet above ground. So it's going to be the radius, which is 30, times sine of the angle, which is 20, and then I have to add 40. So 30 times sine 20 degrees plus 40 will give me the actual height off the ground. So to do that, I'm going to go to Desmos. So here we have Desmos. All right, I'm going to double check that it's in degree mode like I am always supposed to do. I'm going to do 30 times sine of 20 degrees, and then I'm going to add 40 to it. So at the 20 degree mark around the circle, the height above the ground is going to be approximately 41 feet above ground. So if we round that to the nearest whole number, that's about 41 feet above ground. Okay. Now for B, C, and D, I'm literally going to do the exact same thing I just did here, except I'm just going to change the angle measurements. So this is going to be 30 times sine of 90 plus 40. This will be 30 times sine of 150 plus 40. And this will be 30 times sine of 320 plus 40. So if I go on to Desmos, if I go back to Desmos to find the answers for the other two, okay, to find the answers for the other two, and I just realized I messed up on part A. Notice I only put in sine of 2 degrees. I really wanted the sine of 20 degrees. So my answer to A was actually incorrect. It's actually 50.3 feet. So if you thought I made a mistake there, I definitely did. Okay. So to find the answers to the other two, I'm just going to change the angle measurements. First, I'm going to change the angle measurements from 20 degrees to 90 degrees. Okay. So the 90-degree mark is at the high point of the circle up here. So that's going to be 70 feet above the ground. Okay. And then 150 degrees is going to be right here in the second quadrant, about right here. Okay. So that's going to be, I'm going to change that to 150. So that's 55 feet above ground. And then 320 degrees is going to be in this quadrant right here. So let's say 320 degrees is approximately right there. So to get the answer, I'm just going to change this to 320 degrees. And that's approximately 20.7 feet above ground. Okay. The key with this is we wanted to find the y value. We had to use this formula right here because the radius was not 1, the radius was 30. And then to figure out the actual height, I had to add 40 because the center was 40 feet above ground. Okay, so that's number 1. Let's take a look at number 2. As you go around the Ferris wheel, at which positions would be you, that's a typo, at which positions would you be 60 feet above ground? So, at which point would you be 60 feet above ground? So, to find that answer, okay, to find that answer, I need to go to my formula here, okay? So I know that my formula, and I'm actually going to do this on a separate drawing here so I have more room. So I know to figure out the angle, or to figure out the height, I have to do 30 times the sine of the angle plus 40. Okay? So they want to know, when is that equal to 60 feet? When is that equal to 60 feet? Okay? So to do that, I'm going to solve this equation for sine of A. So the first thing I'm going to do is I'm going to subtract 40. Okay. And I'm going to get 30 times sine of A equals 20. All right. And again, I'm solving for sine of A. So to get rid of the 30, I have to divide both sides by 30. So I end up with sine of A equals 20 divided by 30. 20 divided by 30 is equivalent to 2/3. So 20 divided by 30 is going to be equivalent to 2/3. So the angle is going to be wherever the sine is equal to 2/3. So on Desmos, to figure that out on Desmos, I'm going to go back and I'm actually going to graph the sine function here to figure that out. We're going to do this by process of elimination. So let's take a look here. We're going to make this -2 to 2, and we're going to make this -30 to 390. Actually, I need to reverse that. Okay. And I'm going to graph sine of x. And I'm just going to, if I press down on my mouse, I can look for where it's equal to 2/3. Now, 2/3, remember, is 0.66 repeating. So it's going to be, all right, 0.65 at 41 degrees, 0.669 at 42 degrees. So it's going to be at approximately somewhere between 41 and 42 degrees. The first angle is going to be approximately 41 or 42 degrees. If this were a test, I would accept either of those. Okay. And then you could see it goes up to 1. And then I'm going to go down. And I'm going to again, 2/3 is 0.6 repeating. So 0.669 here, 0.656. So it's going to be between 138 and 139 degrees. So to answer the question, okay, at what points will the Ferris wheel be 60 feet off the ground? It's going to be at these 2 points, at the 41, 42 degree mark and the 138, 139 degree mark. Okay, so that is number 2. Number 3, would you ever be 75 feet off the ground? Explain your reasoning. So the key is, where are we the highest off the ground? We're the highest off the ground at the 90 degree mark. And we figured out at the 90 degree mark that we're 70 feet off the ground. So 70 feet is the highest height. That is the highest you will get off the ground. So to answer the question, would you ever be 75 feet off the ground? The answer would be no. And the reason is because the max height is 70 feet. Okay? Because the maximum height occurs at the 90 degree mark, and we figured out that that height was 70 feet. So there's no way you will ever be more than 70 feet off the ground. Okay? Your cool down tonight is going to be based on this one right here, this question right here. So the question number 1 is going to help you with your cool down tonight. That is it for lesson 4, or excuse me, lesson 5.